Hello everyone, hope all of you are doing well. Today we are going to discuss the NCERT textbook exercises and solutions from the chapter Electricity of grade 10. In the previous videos, that is part 1, 2 and 3, we have already discussed the in-text questions and solutions for the same chapter. So if you have not watched the videos, please watch it before going ahead with part 4. Now we can move to the first question. Page number 221 and question number 1. A piece of wire of resistance R is cut into 5 equal parts. These parts are then connected in parallel. If the equivalent resistance of this combination is R dash, then the ratio of R by R dash is, the options are A 1 by 25, B 1 by 5, C 5 and D 25. Here a piece of wire is having a resistance R and which is cut into 5 equal parts. Okay, and then we can have to connect it in parallel. Then suppose the effective resistance of parallel combination is R dash, then we have to calculate R by R dash. So that value we have to calculate. Here the wire is having a resistance of R, and if we cut it into 5 equal parts, what will be the resistance of each part? That will be R by 5 only, right? So if we connect it in parallel, how we can find the equivalent resistance? We have already studied that the equivalent resistance is 1 by R equal to 1 by R1 plus 1 by R2 plus etc. Here we have 5 equal parts, right? So how we can write the equivalent resistance? 1 by R dash is equal to 1 by R by 5 plus 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 1 by R by 5. That means 5 times we have to add it because it has 5 equal parts. Then 1 by R, how we can write the next step? 1 by R dash is equal to 5 by R plus 5 by R plus 5 by R plus 5 by R plus 5 by R. That means 5 times we have to add it together. That will be 25 by R. Then now we can calculate R by R dash. Here we have 1 by R dash is equal to 25 by R. How we can find R by R dash? Then if you rearrange that, we will get the value of R by R as 25. So the answer is D, option D, 25. Okay. Next is question number 2. Which of the following terms does not represent electrical power in a circuit? The options are I square R, IR square, VI, and option D is V square by R. So here we have the 3 equations as the power, right? What are the 3 equations? P is equal to I square R, P is equal to VI, and P is equal to V square by R. So which one is left? IR square. So that is the answer. That is not power. The answer is B. Okay, IR square. Now we can move to question number 3. An electric bulb is rated 220 volt and 100 watt. When it is operated on 110 volt, the power consumed will be, the options are A 100 watt, B 75 watt, C 50 watt and D 25 watt. In this question we have to calculate the power consumed. Here the given quantities are V equal to 220 volt and P is equal to 100 watts. Then V dash is equal to 110 volts. And we have the equation for finding power as P equal to V square by R. And here R is not given, that is resistance is not given. So that we can rearrange this equation to get R. That is R will be equal to V square by P. And we can substitute the values of V and P here. That is R equal to 220 the whole square by 100. That will be equal to 484 ohms. And now if V dash is equal to 110 volts, what will be the power? So that we can substitute the value of V and R in this equation. That is P dash is equal to V dash square by R. That is equal to 110 the whole square divided by 484. That is equal to 12,100 divided by 484. That is P dash is equal to 25 watts. Therefore, our answer is option D, that is 25 watts. The power is 25 watts. Hope it is clear to you. Now we can move to question number 4. Two conducting wires of the same material and of equal lengths and equal diameters are first connected in series and then parallel in a circuit across the same potential difference. The ratio of heat produced in series and parallel combination would be, the options are A 1:2, B 2:1, C 1:4 and D 4:1. Here it is given that the two wires are made up of same material and it has equal length and equal diameter. So each resistance we can take as R. Okay. And first of all we have to connect it in series and then in parallel. Then after that we have to find the ratio of heat produced in series and parallel combinations. If R is the resistance of each, resistance in series and parallel would be Rs and Rp respectively. In the case of series combination, we have the equivalent resistance as Rs is equal to R1 plus R2. But here both the resistance are the same. So that we can write it as Rs is equal to R plus R. That will be equal to 2R. And also in the case of parallel combination, the equivalent resistance will be 1 by Rp is equal to 1 by R1 plus 1 by R2. Here we can substitute R for both R1 and R2. Then we will get 1 by Rp equal to 1 by R1 plus 1 by R2. So that will be equal to 2 by R, or Rp will be equal to R by 2. When connected to a source V, the heat produced in series, suppose it is Hs and in parallel it is Hp. And we have the equation to find the heat as H is equal to I square RT. Here we don't know the value of I, so that we can write this I as V by R. Then we will get the equation as Hs is equal to V square T by Rs, because we are substituting that V by R in case of I. So that will be V square T by Rs, and in the case of parallel combination that will be V square T by Rp. Now we have to find Hs by Hp, that is the ratio of heat produced in series and parallel combinations. So that we have to divide it, V square T by Rs with V square T by Rp. For that we can multiply with reciprocals, right? So that I am writing in one step, that is Hs by Hp equal to V square T by Rs into Rp divided by V square T. Okay. Here V square will get cancelled, and T also will get cancelled. Then what remains is Rp by Rs. That is Hs by Hp will be equal to Rp by Rs. So now we can substitute for Rp and Rs, right? So we have already calculated Rp as R by 2 and Rs as 2R. So we will get as Hs by Hp equal to R by 2 divided by 2R, that will be equal to 1 by 4. That R and R will get cancelled. That is Hs is to Hp equal to 1:4. That is option C is the correct answer, 1:4. Hope it is clear to you. Now we can move to the fifth question. How is a voltmeter connected in the circuit to measure the potential difference between 2 points? To measure the potential difference between 2 points, a voltmeter should be connected in parallel to the points that we have already discussed in Ohm's law. Here we can see that the voltmeter and resistors are connected in parallel. So to calculate the potential difference, we have to connect the circuit in such a way. And hope it is clear to you. Now we can conclude the video here. And in the next video, we can discuss from question number 6 onwards. Okay. If you like my videos, please like, share and subscribe. Thanks for watching.